What I'm going to talk to you about is really giving you an overview of ventilation and indoor air quality standards for sleeping environments. I've already introduced myself, so let me proceed straight to my part of the presentation. I think if you look at the natural and the built environment, various elements, you look at these pictures, the photos, it gives us a very good connotation as to what homes are like. It could be a private property, a bungalow, it could be a landed, setting, or it could be a multi-family dwelling in an apartment. No matter what kind of residential setting we're talking about, there is a place that we call our bedroom, our sleeping environment, that becomes extremely important. We don't give too much attention to the importance of the bedroom environment, but that is what this workshop is all about. Not forgetting the fact that we sleep more than 30 years, at least 30 years, longer for some people, I guess, during our lifetime. What kind of environment would you like our bedroom to be in? Four different photos, images to capture your attention. Extreme left is one setting. Next to it on the right hand side, a real rustic rural setting. The one after that, I don't have to elaborate. You can relate to that in an extremely cold Arctic kind of a condition. And then, of course, the high density, high occupancy, high rise buildings that probably a lot of us are very, very familiar with in today's context. So when it comes to the bedroom environmental conditions, several things that can impact us. Traffic noise and outdoor air pollution, outdoor light. We don't really give too much attention to how some of these parameters that I'm highlighting to you here can impact our sleeping quality or sleeping cycles. Thermal comfort, visual comfort, indoor air quality acceptability, oral comfort or the acoustics related issues, all of this play a very important role when we settle for a good night's rest. There was a systematic literature review done by Ohio et al. Back in 2018. The National Sleep Foundation expert panel, they made a few observations. Appropriate sleep satisfaction will include how one feels about the sleep, how they feel immediately after their sleep, and during the subsequent day. The environmental factors during the sleep, which is in the bedroom environment, include the bedding comfort, bedroom temperature, noise, and light. We already spoke a little bit about that. Sleep initiation, an important aspect of how we start our sleep cycle. The time that we take to fall asleep. Oftentimes we find that we are in our bed, in our bedroom, but it takes a while for us to actually go to sleep. Some of the maintenance parameters during the sleep cycle include things like if we wake up in the night, how quickly we can get back to sleep, the amount of sleep over a period of time, say in a given week, in a given month, and the undisturbed sleep. We can say sometimes I had a very good sleep last night, or we say I had a rather distracted or disturbed sleep last night. So quality sleep for rejuvenation, good health and well-being is very important for all of us. And I think that's important, and we find it increasingly difficult to get that, possible for us in our fast-paced urbanized world. Not easy to come by. So sleep quality is impacted by the bedroom IEQ, indoor environmental quality, which indeed is made up of noise, light, ventilation. It's really most immediately affected by the thermal comfort and indoor air quality. So in this webinar, we'll be focusing, if I'm not mistaken, a lot more on the thermal comfort and the indoor air quality aspects. Let's just proceed. Bedroom indoor air quality and sleep quality research. A lot of the presentations, in fact, almost all the presentations this afternoon, I say afternoon because I'm in Singapore, and today, in today's webinar, this is all about some of the work that's been happening through an ASHRAE funded research project, which Powell will be highlighting and talk more about it as the last presentation. A lot of this work has been done with a team of researchers, and I want to just start with this particular I suppose work that we began with in this team, in this group. It's about trying to understand what is actually known about bedroom ventilation, as well as the standards that we have in today's context. Of course, this work was actually done as a review study back in late 2019 and was published in 2020. You can see all the authors, and several of them are actually speaking today in this webinar. So I just want to give you a very quick roundup of what we found during this review effort. We know that ventilation in any environment is about pull, push, or push-pull. Very easy to relate to how we can get the air to move into the building. And this could actually lead us to look at whether we are talking about, say, something that is related to a balanced ventilation, unbalanced ventilation, natural ventilation, or otherwise. So let me just move further. So the purpose of this review study was to understand what is available. Then we look at in terms of studies done and reported, and then what does the standards tell us, and to also see if the thermal environment has any impact on the sleep quality, as well as the CO2 in that bedroom environment has any impact on the sleep quality. Through the various presentations in this webinar, you will probably get a reasonable idea of what we know and what has been found through our own research in this particular group that I just mentioned. The method that we used in this review was to look at several papers published in peer-reviewed journals using the keyword that you see here, like bedroom, sleep quality, ventilation, IAQ, thermal comfort, CO2, field studies, heating, cooling. So it kind of covers the entire climatic zone range of conditions that we would be interested in. Cut a long story short, more than 200 papers were initially collected. We shortlisted 46 of them, classified them into the 6 different categories to say what we know. And let me just come straight to what we observed. I do not expect you to read every single number. This is a snapshot of what we found from about 17 standards, international and also some local standards specific to a particular country. I just want to show you through a color-coded visualization here. The one that you just saw is about the liters per second per meter square, or in terms of supply airflow provision, or in air change rate, like this is air change rate per hour that the standards talk about. So this is at the whole dwelling or the whole room, not about bedroom, whole dwelling. Then we also have some information about the whole dwelling in terms of the liters per second proper. Then we have something towards exhaust ventilation provided in the various standards. A good number of them show up. How many show up in terms of the bedroom? Not many. The purple that just came up, these are the standards. So the quick observation I want to draw from this particular table and through this simple visualization here is we don't have too much information being presented as requirements from ventilation and indoor air quality standards when it comes to bedroom proper. So there is a paucity of such requirements being specified in bedroom designs internationally, not just in any particular place, internationally. So there is scope to make that better, to improve the provision of these standards. The one that are coming up in purple, dark purple, and the green is just to say that in naturally ventilated environment, very, very little provision being specified as to how it can be achieved. The extreme one on the right-hand side is CO2 level. Is there anything mentioned in terms of what kind of CO2 levels should be in the bedrooms? Not many. Look at the very limited number, and that's the SENS standard actually in Europe. That's what specifies a little bit about what should be the CO2 level. And there's also one standard in China where they talk about it should not exceed, say, 580 ppm. So the long and short of this particular table is we don't have too much information about bedroom requirements. I've summarized that table in terms of specific range of numbers that we get, and here it is. So our observation is very limited information. This is a slide I'm not going to spend too much time. It's just to say that these studies, about 12 of them, I think over here, they were able to relate the ventilation level, lower or higher ventilation level, to sleep quality that they were able to either measure objectively through sleep quality parameters or through subjective responses collected the morning after. I'm not going to spend much time talking about it because the subsequent presentations will address this in a little bit more detail. I just want to show here that in our review, we found about 12 of these papers actually did talk a little bit about the sleep impact. Our conclusions here: most standards on ventilation don't specify anything for bedrooms. Wide range of ventilation rates measured, mostly carbon dioxide concentration and air change rates were measured. This is field studies. And the bedroom temperatures were lower during the heating season, and very little information on how the ventilation rate impacts the sleep quality. That last slide I just showed you, there's some studies, but not many. From that, we could surmise that ventilation rates, when the CO2 level is less than 750 ppm, which corresponds to a certain ventilation rate, sleep quality will not be negatively affected. However, when the CO2 levels exceed 2600 ppm, there is envisaged to be a negative effect on the next day cognitive performance. ASHRAE very recently published what they call residential issue brief. There are two of them, one in June 2021, wildfire smoke hazards for dwelling occupants. So again, an impact on the bedroom environmental quality. And very recently, just last year, about 7 months back, ventilation, IAQ, and sleep quality in bedrooms. I now want to take you through a couple of very quick studies done in temperate climates again, as well as in tropical climate, about field studies that we were ourselves directly involved in. So again, here you see the group that I mentioned as part of this research team, and we studied to characterize the bedroom ventilation performance, or bedroom ventilation characteristics rather, in a naturally ventilated semi-detached house and also in a mechanically ventilated apartment. I wouldn't have time to go through the details. This is one of the several plots that we present in that paper, which is actually published in the ASHRAE STBE journal. A person building up CO2 overnight goes up to 3000 ppm. We did a occupant generated CO2 decay profile study, 0.1 air change per hour because the door was closed. When the bedroom door was open, it increases to 0.3. When we assist that with an exhaust in the bathroom or kitchen exhaust, goes up to 1. Basically, if the bedroom with a trickle vent window is operated with the door open, combined with a local exhaust like in a bathroom or a kitchen exhaust, you have very good air change rate within the bedroom. Mechanically ventilated bedroom, you notice here that all the levels are about 1200, 1500 ppm. In other words, a mechanically ventilated bedroom is able to be maintained at around the 1200 ppm because the mechanical ventilation is able to dilute the room of all the contaminants, of course, including the CO2 as a surrogate indicator here. So the main results and conclusion, again, it's a little bit too detailed for me to go into the details of what this paper presents of our study, but I am just showing you these pictures. Here is the bedroom, a particular bed layout. We changed the bed positions. The room itself, the ceiling height is a variable sloping height. We placed the sensors around the bed in different positions. The idea is we had a protocol that involves several interventions. How much the door was open. Here is the bedroom door. How much was it open? Was it fully open? Partially open? Several protocols were studied. What did we observe? Clear benefit when you keep the NV bedroom door open, I mentioned earlier, assisted with the kitchen exhaust or the bathroom exhaust. The location of sensors, where we locate these sensors here, do make an impact in estimating the local ventilation rate. So it's important when we make these studies in bedrooms, we have to be aware as to where they are located. The position of the bed, whether it is kept this way or this way, we didn't see too much impact in terms of what the CO2 levels were in the breathing zone level itself. And here is just overall summary to say that if we are talking about a similar bedroom or the type we studied, an air change rate of about 0.6 per hour in a mechanically ventilated room was able to keep the CO2 about 1000 ppm. However, when we are talking about an NV bedroom, which now involves the trickle vent and some kind of exhaust, the best CO2 that we can get, or the most typical CO2 levels and the ACR that we can compute, which is around the 0.4 hour air change rate, we find that the breathing zone CO2 cannot be maintained at around 1000 ppm. In other words, NV bedrooms will be underventilated even with the best that we can do with whatever we are able to provide for with the trickle vent and the local exhaust ventilation. We also measured the CO2 emission rate from the CO2 measurements obtained, and we found that both from the NV and trickle vents as well as the balanced MV bedrooms, it was around 7.9 to 10.9 liters per hour person, which was lower than the estimated values using methods that are currently available in standards and guidelines. I'll just sum up and round off my presentation with one last study. This is from our tropical climate setting. This was done a few years ago in residential split system apartment, split system air conditioning unit in a high-rise apartment. Just one slide to tell the story here. We noticed that when three people, two adults and a child, sleep in the bedroom with the bedroom completely closed, air conditioning, split system air conditioning being used, the CO2 level hits about 3000 ppm. This bedroom had an exhaust fan in the bathroom. When we operate that, it drops down quite significantly. So the push really helps, even though there wasn't a dedicated pull really helped, even though there wasn't a dedicated push ventilation, no supply, but exhaust out of the bathroom really helped to bring it down. Now, this part of the study again was to do with what kind of air change rate is possible when the exhaust fans are working in the bathroom. With the exhaust fan, we say that there's 1.96 air change per hour. With exhaust fan off, is 0.32. In other words, in typical residential setting and tropical climate with air conditioning type, the split system type air conditioning being used, we don't have much ventilation. In fact, we don't have any significant ventilation at all to talk about. So this is just to say that you can actually pull from the bathroom, or you can push by keeping the window ajar. Of course, this is like an energy issue here. We can find other means to sort that problem out. So last slide, IEQ, thermal, IAQ, that's the focus of this webinar. Lighting, noise should not be overlooked. All of this affects sleep quality. And that's the end of my presentation. Thank you for your attention. I would now like to invite Professor Leland to proceed with her presentation. Thank you so much.